Hello, my name is Jolie Ballou, and I am your professor for ITSC 1370. I would like to talk to you today about how to change base 10 to base 2 and how to change base 2 to base 10. Before we start, we need to understand why base 10 exists. Base 10 exists because we have 10 fingers and 10 toes. So when we first started counting a long time ago, we said, well, let's base everything on these 10 fingers and 10 toes. And when you were in grade school, you learned a little bit about that. You learned that a number like 3,482 is really made up of groups of 10 and powers of 10. We learned that if 3 was in the thousands place, that meant that 3 meant 3,000. And we learned that if the 4 was in the hundreds place, that meant 400. And we knew that if the 8 was in the tens place, then that meant 80. And if 2 was in the ones place, that meant 2. And what we did was we said, okay, well, we have 3,000 plus 400 plus 82. And that's how we get this number, 3,482. That's how we know what it is. Each of these columns, the ones column and the tens column and the hundreds column and the thousands column, are based on powers of 10. The ones column is 10 to the 0, and anything that's 10 to the 0 is 1. That gives us the 1 column. The next column is tens, and it is 10 to the 1. 10 to the 1 is just 10. The 100s column is 10 to the second, and 10 times 10 is 100. And the thousands column is 10 to the third, and 10 times 10 times 10 is 1,000. So let's look at that right here at the bottom. It's spelled out. 10 to the 0 is 1, 10 to the first is 10, 10 to the second is 100, and 10 to the third is 1,000, and so on. Notice we have 10 digits, but they don't start at 1, because 0 can be a digit as well. So if you look at your fingers, there are 10 fingers, and let's name 10 numbers. 0 is a number, 1 is a number, 2, 3, 4, 5, 6, 7, 8, 9. And because we call it base 10, if we get to 10, we have to go to the next column. So our number selection is 0 through 9. Now, binary doesn't have 9 digits. It doesn't have 10 digits. It doesn't have 16 digits. It doesn't have 5 digits. Binary, bi, means 2. So in binary, there are only 2 numbers to choose from, 0 and 1. And just like our base 10 system, we calculate those numbers as 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on. Why do we have base 2? Computers share data and transmit data and create data packets using only what's considered to be simply on or off. If you think about that, then you can really connect with that it's an electrical impulse. So there's either an electrical impulse, which is a 1, or there's not, which is a 0. And computers represent everything by these 1s and 0s. Now, I'm going to make this part up, but the letter A is made up of 8 zeros and 1s. It might be 1, 1, 1, 0, 0, 0, 1, 1. I'm making that up. I don't have that table memorized. The letter B and the letter C and the letter D, they also are made up of 8 binary digits. So for instance, B could be or might be, and I don't know what it is because I don't have the table memorized, but it also will consist of ones and zeros and could be something like 0, 0, 0, 1, 1, 1, 0, 1. So every letter in the alphabet has this 8-digit number sequence associated with it. That's why we have binary, because computers have to talk to each other in a universal language, which is numbers. Now, let's go straight up here and let's look at this again. 10 to the 0 is 1. 10 to the 1 is 10. 10 to the 2 is hundreds. 10 to the 3 is thousands. And these are places, right? These are like placeholders. This is the ones column, the tens column, the hundreds column, the thousands columns. And if you put a number here, if you put a 5 here in this column, that means 5,000. If you put a number here, it means 100. And so on. When we do the math here, 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3, and 2 to the 4, we get these numbers. Anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the third power is 8. How do we get 8? 2 times 2 times 2. How do we get 16? 2 times 2 times 2 times 2, and that's 2 to the fourth. How do we get 32? 2 times 2 times 2 times 2 times 2 is 32. So when we put zeros and ones through here, it's sort of like, well, it is like the way we do it in our number system. If there's a 1 here, then that value of that column is 32. If we put a 1 here, the value of that column is 512. If we put a 0 here, you don't have anything for the 128's column, so you put a 0 and you don't have anything. And just like base 10, we take all those and we add them up. So let's look at a number. Let's look at this number, 10, 10, 10, 10. This is an 8-bit binary number. How are we going to convert that into a number in decimal that we can understand? We don't want to walk around saying, oh, 10101010.11111. We don't want to walk around saying that. We want to move that or convert that to our number system. So let's talk about how to do that. First, let's line up this number underneath our columns. See how we've done that? 1, 0, 1, 0, 1, 0, 1, 0. And so now, to figure out what it is in our base 10 system, we add up every place we have a 1. Where do we have a 1? We have a 1 under 128. We have a 1 under 32. We have a 1 under 8. We have a 1 under 2, and that adds up to 170. These don't count because they have zeros. 128 plus 32 plus 8 plus 2 is 170, and this is how we say. We go 10, 10, 10, 10 equals 170. In binary, 10, 10, 10, 10 equals 170 in decimal. It's a little bit different going backwards, but let's just say we want to go backward. 170. We have 170 as a decimal number, and we want to change it to binary. That seems like a pretty difficult task, but it really isn't. Let's go backward. If I have a number 170, and I need to put some ones and zeros here, if we start over here, we're going to have a pretty easy time of it. Is 128 less than 170? It is. So if I'm trying to make the number 170 work, then I'm going to have a 1 here in this column. If I put a 1 here, then what I have left is 170 minus 128, and that is 42. If we have 42 to still create ones and zeros in, can we put a 42 here? No, we'd bust like blackjack. If you've put a 42 here, then you've gone over and you can't go over. So we have to put a 0 here. So we'll go to the next one. We still have 42 left. Can we put a 1 here? We can. If we put a 1 here, then we have 42 minus 32. So that leaves us 10. If we have 10 left, what do we do? Can we put a 1 at 16? We can't. We would bust. We would go over. So we still have 10, and we look over here. Well, I can easily see now that 8 and 2 make 10. So I'll put a 1 here and a 1 here. There's no other way to do it. 8 and 4 is 12. 8 is 2 is 10. 8 and 4 and 2 and 1 goes over. So this is how we go backward to change 170 to 10, 10, 10, 10. Now let me show you this. There is a calculator in Windows 11, Windows 10, Windows 8, and so forth. And when you open the calculator, you just do that by searching for it. You need to change from standard to programmer, and then I want to show you something really cool. We have options here. Hex, dec, that's decimal, oct, and bin. Dec stands for decimal, and bin stands for binary. So let's go back and say, what was my number? Look how they got everything grayed out here. If you click binary, you only have two options, 1 and 0. So let's type it. 1, 0, 1, 0, 1, 0, 1, 0. And what does it say if we click decimal? It says 170. Isn't that cool? Likewise, if we clear this and we click decimal and type 170, look at all the numbers we have, 0 through 9, 170, and we click binary, you can see this. Now, not to complicate things, but we do have some other systems. This is hexadecimal. Notice it has 1, it has a 0 all the way through 9, but look, it also has the options to type in A, B, C, D, E, and F. We're not going to do that. That's very, very hard, and we always leave that to the calculator. But we should be able to convert decimal to binary. And if you get stuck, you can always bring up this calculator, because I don't care if you always remember how to do it. I just want to know that you can. So there we are. This file right here is available to you in the Teams app under Files. So if you haven't gone to the Teams app yet, then what I need you to do is go over to Brightspace, find your class, look at content, and if you scroll down, let's click the name of the course up here. If you scroll down, you'll be able to see our Teams area, and we can click that, and we'll continue with our account. And eventually, Teams will come up, and you'll see an option called Files up here. Files, and under Files, and this is taking a long time because I'm recording at the same time, here's our binary to decimal document. So it was wonderful speaking with you and talking to you, and I look forward to talking to you again soon.